Okay, so let's start the session for today. What we are going to learn today is the idea of stability. And if you want to understand the idea of stability, I would like to ask you a question. Have you ever been on a boat or a ferry where you can feel that your body is swaying from left to right? This is due to the current of the ocean or the movement of water that you are on. So what happened there is the body is trying to counteract whatever movement of the body of the ship, the boat or the ferry. So this counter movement is what we call as the stability of a body inside a liquid. So the learning outcomes for today is, by the end of this class, you should be able to understand the theory of buoyancy and stability. I believe we already have covered buoyancy before, and for today we're just going to focus more on stability, and secondly to solve basic calculations on stability. And as usual, we have some definition for you on stability. So the study of stability is a subset of buoyancy, where the equation for buoyancy is used to understand the condition of the body. First, we need to know whether the body is floating or sinking or suspended. So the first thing that we do is we have to make sure that we use FB equals to W, because the idea of stability that we are studying for today will not have an external force. So it's only between FB, which is the force of buoyancy, and the weight itself. So we have to remember, if the density of the fluid is higher than the density of the object, the body will be floating. If the density of fluid is lower than the density of object, the body will be sinking. And if the density of fluid is equal to the density of object, the body will be suspended inside the water. So we are dealing with this buoyancy calculation, and I believe we already understand it from the study that we did in the past video. Okay, there are two different types of stability. Number one is stability of completely submerged bodies. It means that the body itself is fully submerged in the liquid, which means the full body is under the surface of the liquid. Or for the second one, we study stability of floating bodies, meaning that the body is having some part of it above the surface of the liquid. So for both of them, the stability study will be different. Okay, for the first one, the stability of completely submerged body, a body is submerged in fluid is considered stable if the body is able to return to its equilibrium condition when displaced or rotated about a horizontal axis. What I'm trying to say to you today is, if you have a body that is inside a liquid, for example, this is the surface, if it has a movement or rotation to the left or to the right, if it can come back to the original position or equilibrium position, it can be considered as a stable body. But once, if the body is moving to left to right, and it keep on moving until it spins around like this, it means that the body is unstable. So the stability of a completely submerged body is dependent on the location of center of gravity, or we call it as CG, and the center of buoyancy. Okay, we have a friend here. Say hi. Say hi. Okay. So the condition of stability of completely submerged body depended on three different pictures over here. Okay. So before we go further on this, I will explain to you the differences between each one of them. Okay. Okay, the first one, if you check from the picture on the right, okay, the picture on the right shows that we have two different points in a body. Number one is called center of gravity, and center of gravity of a body is located at the centroid of the body, okay? And this is where you have the weight of the body acts downward towards this point, okay? So it is important for you to know the center of gravity will never change at all, even though it is outside of the water or inside the water. It means the center of gravity will stay the same because the body does not change in dimension, size, or weight. Okay? But for center of buoyancy, this is a different condition. A center of buoyancy, CB, is located at the centroid of the displaced volume. It means the centroid of the displaced volume. For example, the displaced volume that we have over here is this part over here. Displaced means it is submerged inside the liquid. Okay, when this is happening, the center of buoyancy only covers the center or the centroid of this part, which is from here to here and up to here. That is the reason why the center of buoyancy will be a bit lower from the center of gravity when the body is floating. What happens if the body is fully submerged? If it's fully submerged, the whole centroid will be under the water, so the center of gravity and also the center of buoyancy will be at the same point, which is here. This is the condition when you have the body to be fully submerged. All right, and from this basic idea, we have three different pictures over here to show to you what kind of stability that we have with a body inside a liquid. Okay, assuming we have this like this, showing that the liquid is on top, so we have the body is inside the water. A body is considered to be stable when the center of gravity is the same as center of buoyancy. This is what I've shown to you at the top. So here is where you have the condition called as neutrally stable. Neutrally stable means it will not change in any condition. It stays the same all the way. Okay, so the body will stay at equilibrium position. It will not move to the left and it will not move to the right. It will stay at the position as it is. Okay, the second part is when you have your center of gravity is lower than your center of buoyancy. So center of gravity lower than center of buoyancy is a condition happens when we tilt or we have an additional weight over here. Okay, when we have an additional weight over here, the center of gravity will become lower because I put aside a picture like this. The distribution of weight will be much higher at the bottom. So instead of the center of gravity is here, it will be a bit lower down here due to the due to the weight that we add in the system. Okay, and because of that, the center of buoyancy will be a bit higher because the center of buoyancy will not be affected by the weight. It is just affected by volume. Because of the additional weight at the bottom, so what will happen? So the center of gravity will be down here and the center of buoyancy will stay up here. So CB will be here, the center of gravity will be here. So remember, center of gravity is not affected by anything, but the CB is also not affected by the weight because CB is affected by volume rather than by weight. Center of gravity is affected by the weight of the system. Okay, and considered to be stable when the body restored to equilibrium position. What does it mean by that? If I tilt the body to the side, as this picture over here, okay, so the center of gravity will be a bit to the left and the center of buoyancy will be a bit to the right. Okay, we don't change the position, it's just the condition when we tilt the system. What happened here is, when this thing is happening, as you learn in static, you will have this moment like this. So this moment is called as restoring moment. So when we tilt it to the side, it will come back again to the left side and become stable again, meaning it will be in an equilibrium position. Okay, I think you guys have seen it before because I think when we are a child, in our childhood, we have something like a toy that looks like this, and then you can push it to the side and then it goes back up again. I guess it's something that you actually have seen before, I guess, in your childhood. Okay, but for the next one, we'll have the condition where the condition is unstable. Okay, unstable is when you have a condition like this. In the original, the top part is having an additional weight. So what happened here is the additional weight on top, okay, will create an instability condition. So when we tilt it to the side like this, okay, center of gravity is higher, center of buoyancy is lower. So when the center of gravity is higher than center of buoyancy, the body will be unstable. What does it mean by that? Because we have a moment like this, instead of helping the body to move to the left, the body is actually pushed to the right, and it will spin until it becomes like this, because this is a more stable condition for our body where the weight is downwards. Okay. The next part is when you have a floating body. This will be different. For submerged body, we don't have any calculation for it. We just have to study in terms of visualization. So you can see, and we have to remember just one thing. If your CG is lower than CB over here, or the CG is higher, it will give you different conditions. So CG lower than CB, it will be stable. CG higher than CB, it will be unstable. That is for completely submerged bodies. For stability of floating bodies, the condition is the same. It's considered stable when able to return to its equilibrium condition. It's the same. It means if I tilt it to the side, like this, floating, tilt it to the side, it will come back up again. So it's the meaning of equilibrium condition. Okay, and the stability for the completely submerged body right now can be considered with three different type of parameter. Number one is center of gravity. Number two, center of buoyancy. Number three, meta center. What's the difference between fully submerged? Is when completely submerged, we only have center of gravity and center of buoyancy. But when we go for floating bodies, we have center of gravity, center of buoyancy, and meta center. Okay, the meaning of meta center is a point of intersection between two lines. Okay, the first line is the vertical line through the point of CG, which the angle is affected by the rotation. And the second one is the vertical line of action of the force of buoyancy. Don't worry, we're going to see it here in this picture. Okay, we still are going to use this picture also because this represents the condition of a body. Okay, but you can see here, you can check on this condition down here. It is different than the fully submerged condition, where for fully submerged, we take the condition of CG and CB, compare it to each other. But for our study in stability of floating bodies, the consideration is between meta center and center of gravity for three of them. Okay. Okay, what does it mean by neutrally stable for this condition? Neutrally stable happens when you have CG here, okay, and CB over here, and we don't have any tiltation to the right or to the left. Okay, it means the center, the metacentric center will be somewhere here. Okay, so this is considered to be neutrally stable. The body will stay at its equilibrium position. Okay, so this is neutrally stable. Number two, condition called stable is when you have the MC is higher than CG. So what does it mean by MC just now? We already learned just now that MC is a point of intersection. Okay, which intersection? First, the first intersection is here, this one. So if you read from the page before, the vertical line through the point of CG where the angle is affected by the rotation. Okay, vertical line means this one. The original vertical line, this line over here. Okay, so that line represents half of the body and half of the body. This is the vertical line. This is the horizontal line. Okay, so what we are going to check is this vertical line over here. If you tilt the body to the side, we assume the vertical line to be the same, which is at the center of the body, and the horizontal will follow the rotation also. Okay, so from here, where is the vertical line? It is this one. It goes through your CG up and it follows the angle of rotation. So this is the vertical CG line. Okay, the second line that is told to you is the vertical line of action of the force of buoyancy. So this is the force of buoyancy. The vertical line will go upward. So this is the vertical line for force of buoyancy. Okay, and you can see this is the point of intersection So this is where you have your MC. Okay, so this is how we're going to check where is your MC through visualization, because later on I will show to you how we can actually calculate the MC, and through the MC you will know whether the body will be stable. MC is bigger than CG, so it's considered to be stable. So the body will store to the equilibrium position. What happened here is weight is going downwards like this, and force of buoyancy is going upward like this. So once again, we will have a restoring moment, okay, as I showed in this picture. Okay, on the right side is a condition where we call it as unstable. Unstable happens when you tilt it too much to the right. Now the body is like this. More of the body is actually inside the water. So the center of buoyancy will also change in position. Don't worry, many people will ask me, how do we know where is your center of buoyancy? Don't worry, the center of buoyancy for this picture is just an assumption so that you can actually see what is happening here. Later on, when we do calculation, we can actually find where is the center of buoyancy. Okay, so assuming the center of buoyancy goes a bit to the left side, center of gravity stays the same position. So what will happen here is this will be the interception between CG and CB. And you can see MC is lower than CG in terms of vertical line. Okay, so when it is lower, it is considered to be unstable. What happened here? It will help the body to turn to the right side, and then the whole body will capsize and it will be upside down, or it can actually sink also. Okay, so this one is called as overturning moment. So right now, what will happen here is I will show you. This is through visualization. We know whether the body is stable, neutrally stable, or unstable.